we have already studied in the signal and system class, means in the signal system subject, that what is Fourier transform. We have already derived the condition for Fourier transform, and this is for Fourier transform for continuous time systems, but here it is discrete time system. So for discrete time sequence, that transformation is needed, because we know that in Fourier transform we obtain from time domain to frequency domain of a continuous time system or continuous time signal, and we can easily represent that in frequency domain, or we can easily analyze the spectrum of the signal, so that in from which frequency to which frequency the spectrum is there, and how to avoid the means co-channel interference. Okay, like that all the conditions can be analyzed easily. So that's why transformation is needed. Similar case for this discrete time sequence also, and but for the discrete time sequence it is called a Z transform. Okay, this is a generalization of Fourier transform. But why generalized? Because Fourier transform does not converge on all sequences. It is specifically for continuous time signals. So it brings the power of complex variable theory, deal with the discrete time signal and system. Let me explain first, then you will easily understand why these lines are written. Okay, so what is the definition of Z transform? So Z transform of a sequence that is xn. Okay, so this is the xn sequence is the input discrete time sequence. That Z transform of that sequence is represented as xz is equal to summation of n is equal to minus infinity to infinity x of n z to the power minus n. And what is z? Z is a complex variable, that is z is equal to e to the power minus j omega. Okay, this omega is the frequency in radian, and that is, if we put this z is equal to e to the power minus j omega here, we will get x of j omega is equal to e to the power j omega summation of x n e to the power minus j omega n. And this we have already seen the Fourier series or Fourier transform is represented like that in the previous subjects. Now what is Z plane? So it is actually the variable, independent variable is in respect to z, x of z. So what is the Z plane? So Z plane, as it is e to the power minus j omega, means it has some real and also imaginary, because it is a complex variable. So that's why the real part, this is the real axis and this is the imaginary axis. Okay, so আমরা যদি এখান থেকে x of e to the power j omega plot করি, x of e to the power j omega, so this is the z actually, z and this is the omega, this is the angle with respect to real axis. And just sorry, just wait. Okay, so this z variable, it is it is at angle of omega. This omega can be varied from 0 to 2 pi, 360 degree it can rotate. So z is equal to e to the power minus j omega. So x of e to the power j omega is summation of xn e to the power minus j omega n. So the Fourier transform is to evaluate Z transform on a unit circle. This is for Fourier transform, and this is to evaluate the Z transform on a unit circle. If its value is unity, then it will be similar to Fourier transform. Now this is simply if a signal is varying complex signal is like that, so it is imaginary and it is the real component, and the projection of that projection is like that. Simply it is a circle with z is equal to e to the power minus j omega. Now what is periodicity? Periodicity means nothing but how the signal is repeating. So if we see that this is the signal, so if the signal is repeating at 2 pi interval, so periodicity is 2 pi. From here again it is starting at pi, so minus pi to plus pi, so it is 2 pi. Period is 2 pi. Now what is these two terms, that is zeros and poles? This is a very important factor in jet transform. So from the previous expression, it is xz is equal to this one with mod. So this mod is nothing but the representing the magnitude. Okay, so this is the summation of n is equal to minus infinity to infinity xn mod of z to the power n, mod of xn and mod of z to the power minus n. This is less than infinite, because the set of values of z for which z transform converges is called the region of convergence, and this is the mod of xz is less than infinite. This is actually region of convergence. Now suppose typically this one is the xz, and what is the ROC from this figure? So ROC will be if this is the r is the radius of the circle, this is the radius of this red circle, then ROC is it is equal to r of x minus mod of z less than r of x plus, then ROC is this condition. So it is the ROC is mod of r to the power is less than rx minus less than r less than rx plus. So this is the actually region of convergence, this shaded portion. And what is the limit? The limit is from rx minus to rx plus. This is the, if this is the center is, if we suppose, then it is rx minus and this is the rx plus. So for stable system, the stable system requires that Fourier transform is uniformly convergent. And for any stable system, if we see that ROC of Z transform include the unit circle, this is the radius of unit, means 1. Okay, so this is the circle. This circle, red circle, having the value of radius is 1. And if this unity circle is lies on the ROC of the system, or ROC of Z transform, then we can say that the stable system is stable from this condition. Now right-handed sequence, we know the right-handed means it has value in the right hand side of the origin. So this is the origin, so this is the sequence. Suppose this sequence has values at the right hand side of 0, at 1 2 3 up to 10. So this is xn. So xn can be represented as a of a to the power n un, and un is the, we know that, unit step sequence. It has value for n greater than equal to 0, and for n less than 0 its value is 0. That's why it is multiplied simply with a to the power n. So exponential sequence. So what will be the Z transform of this sequence? Simply put in the formula which I have explained. So suppose xz is equal to summation of n is equal to minus infinity to infinity a to the power n un z to the power minus n. Just simply put this in the formula of xz. So if you will get from this formula that it is the infinite, minus infinity to infinity was the limit, but as un is multiplied, so what will be the limit now? It will be the from 0 to infinity, means it is in the right hand sequence. So the now it will be simplified as a to the power n z to the power minus n, or simply you can write also that a z to the power minus 1 to the power n. Now what is for convergence of xz? So for convergence of xz means how to get convergence of the xz? The convergence condition is that this value, mod of this value will be less than infinity, then it will be convergent. Or mod of a z to the power minus 1 should be less than 1, because it is, if we simplify that we will get this. Or simply this is z inverse, so if z inverse goes to this side, then mod of z will be greater than mod of a. So xz is equal to summation of n is equal to 0 to infinity a of z inverse to the power n. This from this is well known mathematical formula. From that we can see that it is 1 by 1 minus c. It is, if it is summation of n is equal to 0 to infinity c to the power n, then it will be 1 by 1 minus c, like that. Here c is the a z to the power minus 1. So if we put this, then 1 by 1 minus a z to the power minus 1. Or simply simplify, then we will get z by z minus a, where the condition for convergence is mod of j greater than a. So for right-handed sequence, for ROC, the right-handed sequence ROC for xn is equal to a to the power n un will be xz is equal to z by z minus a, and mod z is greater than mod a. So ROC is this shaded portion. This shaded portion shows that mod of j greater than mod a, or this is the value a minus a, this is plus a. So after that za means, if you put a unit, if you get a circle with radius of a, then means above that circle this portion is the ROC. And what is the unity circle in this case? Unity circle is that it is the below that ROC. And it may be also that if a value is less than 1, then it will be in the ROC. So which one will be stable? As in the previous case, I have told how to get stability. This one is the ROC, it lies in within the unit circle. So unit circle lies within the ROC. This is the stable. Now left-handed sequence. So it was the right-handed previous case. Now is the left-handed sequence. So for left-handed sequence, xn is equal to minus of a to the power n u of minus n minus 1. So this is the left-handed sequence. It has value from below left hand side of the origin, and its value is at minus 1. This is the amplitude, this one, minus 2 this one. So this is the exponential decaying also. So, and the amplitude is in the negative side, that's why it is minus of a to the power n. And this u of minus n minus 1 representing the unit step sequence for values is less than 1 having the value, and for greater than 0 it has value 0. That's why it's multiplied with u of minus n minus 1. Okay, now আমরা আবার ওখান থেকে xz পেতে পারি, that is the z transform of this sequence. So z transform করলে আমরা এখান থেকে summation of n is equal to minus infinity to infinity minus of this one a to the power n u of minus n minus 1 z to the power minus n. So from this we will get that minus of summation of n is equal to minus infinity to minus 1. Previous case it was the limit was changed from 0 to this one, but in this case as it is from minus infinity to minus 1 is the, because this is delay with minus 1, that's why there will be minus 1 is the limit. So a to the power n z to the power minus n. Or simply you can write that if minus if we take the minus, in this case it is minus here, and then it will be n is equal to 1 to infinity a to the power minus n z to the power n. Okay, so if you put this minus limit in this case, then it will consider like that. or simply if we put the n value is equal to 0, first case, then it will be 1, it to the power 0, and z to the power 0 is also 1. So 1 minus n is equal to 0 to infinity, e to the power minus n, z to the power minus n. So ROC will be this term, mod of this term will be less than infinity. So if this term is less than infinity and this is the ROC case, A inverse z less than 1 or z greater z less than A, and xz will be simply if we this is the formula, this is the expression. So 1 minus summation of this one, it will be can be written as 1 minus of 1 by 1 minus this term. Okay, so then if we simplify this one, we will get the z by z minus A, where mod of z is less than mod of A. So for the left-sided sequence, ROC of this expression is this one, xz is equal to z by z minus A. It is the z transform of this sequence, left-handed sequence, with the ROC is mod z less than A. Previous case was mod z greater than A. In this case, it is the mod z less than A. So here mod z is, it is the ROC is below the A, so it is the ROC means shaded portion, and this is the unit circle, so it is lies within the ROC. So this is now stable, and this is one case where, because it may be plus 1 plus A minus A, so that's why it is the ROC is this one, and unity circle may go outside of the ROC. Which one stable? So this one stable because unit circle lies within the ROC. Now for a rational person, means rational means it is a just this is the pz xz, which is considered as pz by qz. These are the rational. Okay? So pz and qz are a polynomial in z. It is with the polynomial with variable z. Then for this case, the 0 is 0. What is the 0? Zeros is considered that the values of z is such that xz is equal to 0. And what is the poles? Poles is considered that the values of z is such that xz is infinite. So which case is the infinite will come? So if it is 0, qz is 0, then something by 0 is infinite, and zero's case is if upper term or numerator term is 0, then xz will be 0. So it is the 0 poles, and it is the upper one is for 0 and the lower one is for poles. So for this right-handed sequence, this is the condition. And this is the pole, this is one, z is equal to A. Z is equal to A is the this point, this is a cross red portion, red dot, and this is the actually z is equal to 0. Okay, so this is the pole, and this is lower portion is the pole, you know that, and upper is z is equal to 0. Here nothing is there, so nothing means z minus 0. So z is equal to 0 is the 0 term. That's why it is circle with the blue sign, blue color. This is the 0 and this is the pole. And the ROC is this shaded portion. So ROC is bounded by the pole and is the exterior of a circle. This is ROC. Its ROC is bounded by pole. This is the pole. So pole is in the ROC boundary, and it is exterior of a circle. and this is a left-handed sequence. Case 2. So in case 2, if the ROC is inside of the circle, this is the shaded portion, then ROC is bounded by the pole and interior of the circle. This is the interior of the circle. Okay, this is two cases actually. We will see a lot of cases in this. Then we will do some mathematical some example we will do in the assignment class. Now example is sum of two right-sided sequence. This is the two sequence, both are the right-handed sequence because this is un, here also un, so both are right-handed sequence, and this is actually half 1 by 2 to the power n. So 1 by 2 is a is this 1 by 2, and here a is 1 by minus 1 by 3. So what is the xz from xn? How to get xz? A to the power n un. What is the xz? Can anyone tell me? That is the z by z minus a. So this is z by z minus a. A is the 1 by 2, so that's why z by z minus half, plus this one, this one's z transform will be z by z plus 1 by 3. So this is the z by z plus 1 by 3. Okay, so if we simplify this, we will get this expression to z by into z minus 1 by 12 by z minus 1 by 2 into z plus 1 by 3. This is simplification from this expression only. Now simply put these poles and 0 in the real and imaginary axis. So what is the poles and what are the zeros? So upper portion is 0, so at 0 there is 2 0, at z is equal to 0 is a 0, here will be 1 0, and z is equal to 1 by 12, z is equal to 1 by 12 come in this side, so there will be a pole, sorry, there will be a 0, so circle will be there, blue circle, and two poles is there, z is equal to 1 by 2 and z is equal to minus 1 by 3. So minus 1 by 3 means it will come in the negative side, two poles, one pole here and one pole will be z is equal to 1 by 2 at the right hand side. So let's see that. So it is seen that it is at the 0 origin, at the 1 by 12 also there is a 0, and two poles, one is at the minus 1 by 3, this is for minus 1 by 3, and this is at 1 by 2, so this is the 1 by 2. Now ROC, for this case ROC is, you know that it is mod z greater than a, so it is outside of circle, so this ROC is outside of the circle bounding this pole. So ROC is bounded by poles and exterior of a circle. It is the bounded by poles, this is the poles, and it is exterior of the circle because it is mod z greater than a. And does not include any poles also. ROC in this case, it does not including any pole, it is at the boundary. Okay, now two-sided sequence. This is a two-sided sequence. If we see that minus 1 by 3 to the power n un minus of 1 by 2 to the power n u of minus n minus 1. So this two-sided sequence, if we simply put means z transform, then xz is, this is z by z plus of 1 by 3, this is the a portion, so z by z minus a is minus 1 by 3, that's why z by z plus 1 by 3, and for this case it is also z by minus of 1 by 2 to the power n is there, so this is z by minus means z minus of 1 by 2. So that is 2z into z minus 1 by 12 into z plus 1 by 3 into z minus 1 by 2. So simply put the pole and 0 in the real and imaginary axis. So this is the 0, at 0 z is equal to 0, Z is equal to 1 by 12, there will be a 0, so 1 by 12. Z is equal to minus 1 by 3, this side will be a pole, and Z is equal to 1 by 2, this side. And as it is two-sided sequence, so what will be the ROC? In this case, for this ROC is greater than A, and for this case less than A. So both case, that's why it is an annular ring. Okay, so for this case it is ROC is greater than 1 by 3, so it is exterior of this pole, and for this case it is interior of 1 by 2, this is interior of the pole, that's why the ROC now is a annular ring. Okay, this is the annular ring. So now the ROC is bounded by poles and a ring. This is the ring, ROC is ring, and it is bounded by poles. It is the one pole is at the outer boundary, and at the inner boundary there is another pole. Finite sequence, suppose xn is equal to a to the power n, where n is in between 0 to n minus 1. This is a finite sequence because it is not up to infinity, its value is from 0 to n minus 1. So xz for this case will be n is equal to 0 to n minus 1, this is the limit, so n minus 1, and a to the power n, z to the power minus n, so n is equal to 0 to n minus 1, az inverse to the power n. So this is from this mathematical formula we know that it is 1 minus a to the power n by 1 minus a, sorry, 1 minus az inverse to the power n by 1 minus az inverse. If it is x to the power n, then 1 minus x to the power capital N by 1 minus x. Simply put this x value as a of z inverse, then we get this simplified version. Then again it can be written as 1 by z to the power n, because if we put this z inverse in the common, then 1 by z to the power n minus 1 by z to the power n minus a to the power n by z minus a. So what are the poles? So there is n minus 1 poles, because 1 by z to the power n is there in the denominator, so this and this is z is equal to a. So how many poles? N minus 1 poles is there in the origin, and n minus 1 zeros also there in the boundary of the circle. So n minus 1 0, because z to the power n minus a to the power n, this one will give the zeros. So how many zeros? There is n minus 1 zeros. So ROC is from z greater than 0 to infinity, less than infinity. And this system does not include any pole. So which system does not include any pole, that system is stable. And in this case also, this system ROC does not including any poles, and it is stable. So properties of ROC, region of convergence. A ring or disc in the z plane, center at the origin, and the Fourier transform of xn is converged absolutely if the ROC include the unit circle. So Fourier transform of xn is converged, even having convergence if the ROC is including the unit circle, as we have seen in the example. Some ROC is having the unit circle. The ROC cannot include any pole. We have seen that ROC is bounding the poles, but it does not including any pole. Okay. The finite duration sequence is ROC is entire z plane except possibly at z is equal to 0 or z is equal to infinite. So finite duration sequence having ROC completely z plane. In the previous case, that is this is finite duration sequence. Its ROC is completely z plane except that z is equal to 0 and infinity. And for the right-handed sequence, it is extend outward from the outmost finite poles in xz to infinity. It is the outside of the circle. And for left-handed sequence, it is inward of the innermost non-zero pole. Suppose there is a number 3 poles is there in the right hand side. For this case, what will be the possible ROCs? Let's find out the possible ROC. Case 1 is a right hand sequence. Suppose the sequence is right handed, then one of the possible case is that ROC is from at this C to minus infinite, because ROC does not include any poles. So this shaded portion is extending to infinite to C outside of the circle C with C radius. Okay. Then case 2 is the left-handed sequence. Previously right hand, now left-handed sequence. So what will be the ROC case? So for left-handed sequence, the ROC is inward of the lowermost poles, means low, that is inward of this smallest pole, that is A. This is one case, and next case will be two-sided sequence. For this case, what will be the ROC? So this case ROC will be in the annular ring, and it is extending from A to B, but it does not include any poles. Another two-sided sequence will be there. This is the another two-sided sequence with from B to C. This is the ROC. Now some specific bounded signals example. So bounded signals, that is RAM output, this one. This is exponential sequence, and this is the typical sinusoidal sequence with samples at some sampling intervals, and this is also exponential decaying sequence, okay, with samples at sampling frequency or sampling time. And this is two-sided sequence. In the both positive and negative axis is their value alternatively, and this is a damp sequence with damping oscillation. So is this bounded sequence? No, because this ramp output signal, its value continuously increases and it will goes to infinity. It is also case in this case also exponentially increasing values, so it will also not bounded. But this one is bounded because its value is fixed, either 1 or -1. So it is bounded, it is bounding oscillation. And this one also, because its value starts from 1 and goes to 0, so it is bounding also. It is not bounded, and in this case it is also bounded because damping oscillation, the value goes to 0. Now what is Bibo stability? Bibo means bounded input, bounded output. So what is bounded input? If the input is bounded, the output is also to be bounded, and if the input is unbounded, so output to be unbounded also.